In this video, I'm going to introduce a computer as a concept and a tool and talk about how an Arduino is kind of a subset of these computers. So let's kind of start by thinking just specifically like, what is a computer? What is the definition of a computer? So a computer is sometimes defined as a machine that can be instructed to carry out sequences of arithmetic or logical operations automatically. So it's basically just some type of machine. And if we think about kind of the advent of machines, right? Machines were invented as a way to kind of amplify or extend our physical abilities. So some of the first machines were used in like agricultural practices to kind of help with harvesting, various like things like corn and things like that. So a computer is just kind of a new form of machine that instead of being able to really amplify or extend our physical abilities, it's meant to kind of amplify or extend our computational or mental capabilities, right? So computers was just a name for a job that somebody had where they would compute values, right? And so a computer was first a person, and then it kind of became a thing where its first job was kind of doing these complex mathematical computations. And now we kind of use them for all sorts of different things. And we're going to kind of talk about different forms of computers here. But really, computers are just a dumb machine. They do exactly what we tell them to do. And so if they're doing something wrong, 99% of the time, it's because we told it to do the wrong thing, or we asked it to do the right thing, but in the wrong way. So I know computers now are really complex and they're running all sorts of different software that we don't really have control of. So it's more kind of on those people if it's doing something wrong. But here in this environment on the Arduino, we're going to be writing all of our own software. So if it's kind of misbehaving, it's probably due to us asking it to do something wrong. Because again, it's just dumb. It's doing exactly what we tell it to do in this explicit set of instructions that we're giving it. So, kind of in conclusion, a computer is a machine that can like accept some input, execute a procedure, and produce an output. We can kind of think about it as a brain with different receptors to receive input, think about these things and produce some output. So computers kind of have three key parts, right? They have some sort of input or output, where like the input of your computers would be like the mouse and keyboard, and the output would be the screen visually displaying information or the speakers. And then there's like the processor, which is processing kind of what it's supposed to do. And there's memory, where it can store information in your programs and files and all that stuff. So that's kind of at its core what a computer is. And programming is basically how we tell computers what to do. We write things in a programming language to instruct and communicate with a computer to tell it explicitly what we want it to do. And so kind of the key point I want to drive home here is this idea of levels of abstraction. So there are these different kind of hierarchies of abstraction where we can ignore kind of superfluous, irrelevant details, right? So an example of this could be like, if I'm walking around the room, right? I'm just thinking, hey, I want to walk over to this corner of the room to, grab this thing off my desk or whatever. I'm not, thinking about each individual muscle fiber and how it has to move in order for my legs to step 1 foot in front of the other, right? That is abstraction, right? I'm just saying walk to this corner of the room, and then my body takes over and kind of does all the low level stuff to say, hey, move the muscles in this way or that way. And so oftentimes in talking about computers, there's like this idea of software and this idea of hardware, and they're kind of thought of as separate things. But the point I really want to drive home is that they are the same thing. They are just exist at different levels of abstraction. So like this is a view of a computer chip, kind of similar to the chip that is on the Arduino. And so there are things happening at this very low hardware level, but we don't have to worry about that because somebody has written code and like developed processes for converting our software, so things that look something like, hey, let's create some value A that is equal to 8 plus 7. It will do all the nitty-gritty details to make this operation happen. So all we have to do is think about this. We don't have to think about all these really complex routing of all these individual little bits inside of the chip. So that's what I want to drive home, is that software is hardware. It's just at a different level of abstraction. And for our purposes, we're really just going to worry about, the highest level of abstraction, where we can write in a programming language telling the Arduino what we want it to do, and it will then interpret that and then run it at the very low level there. So what is a microcontroller? the Arduino Uno is a microcontroller. It's basically just a special purpose computer that's really good at being fast responding to certain stuff because it doesn't have a really bloated, operating system where it's checking like Discord notifications and things like that. It's just a very low level form of computer that's low cost and can react very responsively to various forms of like input and output, and has a nice means of connecting all sorts of different things like lights and motors and various sensors to get in various input sensory data. So that's what a microcontroller is, and that's an Arduino Uno is a form of microcontroller. And so yeah, we want to use these because they're low cost and they can do things in real time. They can react very close in real time. And you actually, whether or not you've heard of the term, they're kind of all around you. There is, you could find them in all sorts of medical equipment. There's like, dozens of them inside of every vehicle controlling like the braking system, the steering system, all sorts of different things. You can find them anywhere. But yeah, so this is what we're going to be using here. So let's talk specifically about the Arduino Uno. That's kind of a more close-up view of what it looks like here. All right, so there is this thing on there. It's this chip right here that's called the Atmega 328, and this is the actual microcontroller chip. All these other things are just kind of supporting characters to kind of help us interface with this chip. But this is the brains of it right here. And so there's all these crazy terms here, and if you pull up this data sheet for that specific chip, it's over 662 pages long, which is mind-numbing, and there's so many like minutia and fine details inside of there. So what Arduino is just a company who has developed this open source platform for this specific chip and abstracted away a lot of those nitty-gritty details so we don't have to read this big long data sheet. They've created this whole environment and programming language where we don't have to worry about a lot of those details. They've kind of done some of the work for us so that we can just get right to making this thing work and control motors and lights and all that sort of stuff. So that's what this is really good at. And so what we're going to do is kind of talk about this thing as a tool before we get into talking about the programming language and how we can actually control it. So let's talk about the capabilities of what it does. So the first thing is there's two little jacks right up here. So this is like a barrel jack that you can use. I'm trying to see if I have one around. I guess not. But you can plug in, a little 9-volt battery or some sort of external wall wart power supply that provides 9 volts to power it. Or oftentimes what we're just going to do is we're going to power it via like a USB cable like this here. So that is just going to plug right into here, and then it's going to plug in the other end to your computer so that you can control stuff. And you can send new programs to it and kind of tell it what to do. So that's what these two things are. And then this is the big chip here, and then all this other stuff is just kind of used to help it out, right? So up around here is a lot of circuit components to help limit and control the power coming in to make sure it's not too high or too low. This right here is something that's used for communication between your computer and this chip here. It's kind of an intermediate chip. This is a crystal that helps get the timing down for when you're doing communications. It resonates at a particular speed and frequency so that we can communicate back and forth. And then, again, this is the big chip here. And then on the ends here are these headers, we call them. These are different kind of sockets, again, where we can plug in little jumper wires and route it out to a circuit. So now, instead of controlling circuits just by wiring it up or using switches, we can actually route our circuits to the Arduino to have it, drive different LEDs or read in information about whether or not a button is pressed or connect to different sensors and stuff like that. So that's what all of these different headers are for. These are connecting us to certain pins within the Arduino that we can then control. So it's kind of split into two halves. So over on this right side here, we see digital. So these are digital pins right here. And what digital means in this context, right, is like you might have heard of distinctions between like digital or analog music, where digital means, it's represented on a computer, whereas analog is something like a tape or a record or something like that. So what digital means in this case is it's just represented as one of two states. it's either represented as on or off. And so in computing, we call this binary. It's the two different states that we can use to store information. And actually, when we're talking about music files being stored digitally, it just means that those music files are stored as a sequence of zeros and ones to store all that data about, like, what notes are being played and all that different stuff. It's stored as a series of 0 and 1 on a computer, because that's how a computer works. A computer works on binary systems where inside of like all the different circuits that are inside of this chip, things are either on or off. They're either a 0 or a 1, where 0 corresponds to off and 1 corresponds to on. So what digital means here is that these pins can either be on or off. And so for our Arduino, it operates at 5 volts. So when these pins are on, they are providing 5 volts from the pin or from the header there. And when they're off, it's providing 0 volts. So you can see how that would be helpful for like turning on and off an LED or turning on and off a motor and various things like that. So that's some of the things that we can use these digital pins for. Digital pins can also be used for communication. So just like we can represent those music files as a stream of zeros and ones, we can communicate data as a stream of zeros and ones using like different binary communication means. And so since these things are really good at switching on and off very fast between 0 and 1, we can communicate a lot of data in a short amount of time. So that's another thing that these pins are used for. So we have 14 of these digital pins that are numbered 0 through 13. And so they can be used as digital outputs, meaning that they are outputting some voltage, either 5 volts or 0 volts. Now, there are some special purpose things here. So down here for pins 0 and 1, they are labeled as RX and TX. What we're going to do is we're going to try to avoid using pin 0 and 1 for all of our circuits, because this RX and TX pins here, they are used for communication through the USB port to the computer. And sometimes if you're trying to use them for something else in a circuit, there could be some conflicts and you might lose communication with the computer, which is important because that's how we send new programs to this. Now there are ways around that, but for the most part, let's just try to avoid using pins 0 and 1 here for our digital pins. And then there's these other ones here with little tildes next to them. It says something about PWM here, which is something we're going to circle back around to. But yeah, so we have 14 digital pins that we can use. And I kind of talked about how they could be used as outputs. They can also be used as inputs, meaning we can read in information to determine whether it's a 0 or a 1, basically where a 1 would respond to we're receiving 5 volts on the pin, and a 0 would correspond to us receiving 0 volts on that pin. So that is kind of this side of the board over here. We also have a ground, which is something that we'll use later on. It is kind of the return path, similar to our like negative side of our rails here. That's where we need to go back to complete a circuit. So it needs to travel. If we're trying to drive an LED, it would leave the digital pin. It would send out a digital voltage at 5 volts. It'll go through a resistor, through an LED, and then it will come back through and we would connect it up to ground here. So that is kind of everything here on this side, right? So we have digital pins and they can either be used as an input or an output. Now over here, we have kind of two different sections here. There's this stuff labeled as power and this stuff labeled as analog in. So over on power, we kind of have a couple pins here that we don't really care about, this IO ref or reset. This is going to provide you 3.3 volts, which we won't ever really use. We will sometimes connect up here to 5 volts if we need to provide 5 volts. And then those ground pins here, there's 2 of them, are going to be used again as a path for our current to return back so that the circuit is complete and there is a complete flow of electricity there. And then VN is something else again that we probably won't use at all. But now we have these. These are analog in. And so I talked a little bit about digital, which is representing information as a stream of zeros and ones. And then we talked about, like analog music, which would be like something recorded to like a tape or like a vinyl record or something like that. That is representing music in an analog meaning that there's kind of an infinite range of values that we can use to store information. So these are labeled as analog inputs because they allow us to read in information with a little bit more granularity than we do with our digital pins. So our digital pins can be used as an output or an input, and when they're used as an input, we basically only know whether or not something is on or off, whether it's 5 volts or 0 volts. But over here for the analog in, we can read a bunch of different values in between 0 and 5 volts to give us a bit more information about what's going on. So this can be helpful for reading like certain types of sensors or different things about what's going on in a circuit. That gives us a lot more granularity. So we have 6 different pins here, and they're labeled A0 through A5. And so that's kind of everything here that we have at our disposal. And by using these different pins here and connecting it up to circuits, we're going to be able to do like almost infinite number of things. There's so many different possibilities. But yeah, I guess the key distinctions here that we want to make is digital versus analog. So digital, there are 2 states, on and off, either 5 volts or 0 volts. And then analog, which has a whole range of different values between 0 and 5 volts. And then digital, we can use as an output to drive out a voltage, or we can use as an input to read in a voltage. But the analog pins, we could only read in voltages from. So that's kind of basically everything this can do. There are some more slides here that kind of break down stuff pin by pin by pin and talk about a lot of what I just said. But yeah, so in the next video, I'm going to talk a little bit more about the specific programming environment and how we can get set up to send some code to this.